In this question, we are asked to find the total length of the belt that is holding the two pulleys centered A and B. So we have got a pulley here and another pulley there. And now the length of the belt that's holding the two pulleys will be from R to S, that is the length of that line, the length of the arc SM, the length of the line MQ, and the length of the arc RQ. So the first thing we do is we get the length of the line SR. First thing first, we draw a perpendicular bisector to line AS, a line that divides AS into two equal halves. And that line will directly go to the center of B. So this is a line that's perpendicular to the line AS. That means that the angle formed here will be 90 degrees. So I want you to notice that the broken line, the red line, and this black line will form a triangle, a right-angled triangle at that point. Let's call it even X. We can be able to get the height of this triangle by using Pythagoras theorem, because this line is going to divide line AS into two equal halves. That is 5 here and 5 there. So the base will be 5 centimeter. The height, we don't know, we're looking for it, and the hypotenuse is 50 centimeters. So the height squared is equal to 50 squared minus 5 squared. This gives us 2,500 minus 25. Therefore, the height will be the square root of 2475. And this will give us 49.74. So this will be 49.74. I want you to notice that line SR is tangent to the circle centered at A. That means this is 90. This is 90. Also, line SR is also tangent to the circle at centered B, which means this is also 90 degrees. So we are going to form a rectangle here with a width. This is the width and this is the length, which means this is also 49.74. The next thing we are supposed to do is find the length of the arc SM. The length of any arc is given by theta over 360 times 2 pi r, where r is the radius of the circle, in this case 10. Theta is the angle subtended by the arc. The arc SM, the angle subtended, is this angle. So if we could get the total of this, we can get this small angle. So if this is 84.26, this is also 84.26. When you add them together, the total of that angle is 84.26 multiplied by 2, which gives us 168.42. Since we have the total of this as 168.42, we can get the total of these by subtracting 360. We'll have 360 minus 168.42. This will give us 191.48 degrees. So we have our theta here now. This will be our theta. And now we use the formula, length of the arc equals to theta, 191.48 divided by 360 times 2 pi is to 2 over 7 times the radius 10. This gives us 33.43. So we know the length of this arc, and that is 33.43. Step is to get the length of the line MQ. Here, we are going to use the properties of tangents from an external point. This circle centered at A have got two tangents, SR and MQ, drawn from an external point. The property is that the length of the two tangents will always be equal, which means that MQ is also equal to SR. This will be 49.74. Now, our problem is solved for the length MQ. We expect this length to be 49.74 centimeter. Our last step is to get the length of this arc RQ. And the only way we can get is to use the formula length equals to theta over 360 times 2 pi r. In this case, the radius r of this circle is 5. But what we're lacking is this angle theta. Now, for us to get this angle theta, ideally this angle is equal to this one. So I expect this one to be 168.42. I will show you why. Suppose we draw a line from here, again, a perpendicular bisector of line AM, and join it to the center of the circle B, which means this angle will be 90, and this is also 90. Look at a certain triangle. Let's call this one Y. Look at triangle AYB, right angle at Y. We could get the angle, this angle, small angle, because we know that 84 plus 90 plus this angle, let's call it angle X, is 180. That is the properties of triangles. Angles in a triangle add up to 180 degrees. So 84.26 plus 90 plus that angle, we don't know X, let's call it 180. Then X will be 180 minus 84.26 minus 90. X will be 5.74. So this angle is 5.74. We expect this one to be also 5.74 because this is also 90 and 84.26. That is triangle AXB. We expect this one to be also 5.74. So the whole of this means 5.74 multiplied by 2, which gives us 11.48. So this is 90. This is 11.48. This is also 90, because if this is 90, this is the tangent, which means the radius and the tangent will meet at 90. The radius and the tangent will meet at 90. We have 90, 90, 90. We expect this one also to be 90 degrees, which means that the whole of this angle you see here will be 11.48 plus 180, which is 191.48. The total angle. So if we want to get this one, it is 360 minus 191.48, which gives us 168.42. So with that, now we have our theta, we can get the length of that arc. The length is theta 168.42 divided by 360 times 2 times 22 over 7 times the radius of this circle 5. This will give us 14.7 centimeter. Now we have everything. Now we can be able to find the length of our arc, which is, we said, RS plus the length of this arc SM plus the length of MQ plus the length of RQ. So the length of belt is equal to the length of SR 49.74 plus the length of the arc SR, which is 33.43, plus the length of MQ, which is another tangent, 49.74, plus finally the length of the arc RQ, which is the final one, 14.7. This will give us a total of 147.6 centimeter.